No, the it's freaking more. It really makes sense. When yeah. Yeah, it's the tension. That's fine. We even have the magnets inside. It's hard to. They had the magnets, and whenever I've tried to fill them, it's very. Yeah, because I saw it really expensive too. And then the page doesn't work, and they're like, yeah, something I want your iPad, and it's making 3 of them. Like, he didn't make it. I'm like, I mean, now I suppose we're gonna get moved over 5 all homework for me. I don't know why, but everything else, it's so nice. And it's kind of hard. 5 minutes. It's like yes, I and so kids and everything. I have like to do wait. I would go one push down. Yeah. Good job. Yeah, and the question is, if it's the things that I do about and then it's like why they was really bad. There's the last one.
My friend is in another section. I was really recommending this. I was like, would it be okay to let him tell his wife from experience, like get for maybe get more practice and stuff in the class and stuff. That's all. Yeah, I told him. That's what I was telling you. I said a lot of people just don't come because he gives us the responsibility of, you have something to do, go do yourself. And I was telling them that you should really come try it. And it'd be interrupting. I said, you're lucky. I said, your name's not on the email. So you don't ever come, you don't have to come walk to the front. I said, you're lucky. You're just the hidden like there.
Yeah, that's fine. Yeah, that's fine. Yeah.
My friend is you might be a little lost because I'm the first thing. Just want to say like, oh,
Okay, so let's get started. Okay, so let's first talk about the office hour tomorrow. Okay, so I know everybody's actually preparing for your midterm for now, and then you might need some extra help. So I can do extended office hour tomorrow. Okay, so the original office hour is actually from 9 to 11, right? I can do from 9 all the way to probably 3 o'clock because I have to go back and pick up my kids. Okay, so let's actually probably the longest time I can do. Okay, you can come before 9, it's fine. Typically it will be in my office at 6. Okay, so 6 to 3 is the time you will be able to find me in my office. Okay, and my office is at Fleming 139E. Okay, so just come. You don't need to reserve. Just come. Okay, I will be there. Okay, if you don't see me during the lunchtime, you know, be sympathy. Okay, I may actually go out and have something. Okay, but I think most of the time I will just stay in my office. If you want to actually make sure you can actually find me, you can also email me to tell me, okay, when you are going to arrive. Then I'll be waiting for you in my office. Okay, so that's actually the first thing I want to make the announcement. Second question we can see here is actually you guys want the lecture more practice problems, right? So you guys have, okay, this is actually what I tell most of the students, okay, which their major is not chemistry. Okay, I think most of you are not chemistry major. Okay, so I don't know how much time you're willing to spend. Okay, but if you want to really do well for this specific course, the things that you will need is really, you guys do the quiz, right? So make sure you actually know every single question you encounter in the quiz. That's actually step number 1. Okay, number 2 is actually, we actually went through a lot of questions in the Hangout. And also this midterm 1 review, right? Make sure you know all the concepts that you need to know. Okay, this will actually include all the concepts you will need, okay, for your midterms. Okay, nothing more. Okay, this is Gen Chem. This is not rock science. The things you need to know is actually very limited. Okay, how limited? The 3-page hangout that I provide is actually all the things you need to know. Okay, so anything outside that is beyond the scope. Okay, I would actually encourage them to spend more time, beyond those 3 hangouts. Okay, so you can also see there's actually someone who haven't really started to study yet, right? So are you cooked? So I will leave the answer to yourself, right? You are the one who can to answer this. Okay, I don't know how determined you are, right? If you are super determined, then you can actually pick up all the content we actually went through in the past 3 weeks. You will be fine, right? But if you are not, then you're not. Okay, so who will make the decision? You, not me. Okay, so let me emphasize again. What is my role here? I'm just a helper. Okay, I'm nothing big. Okay, I'm just a professor who's trying to help students. That's all I can do, right? Who is going to determine your grade? You, not me, right? So I hope lecture provide a more correct physiological, no, not physiological, the philosophical thought that you should actually have for the specific questions. Okay. All right. So the very last question we have here, we only have 4, or we have more. The exam multiple choice. The exam will actually very similar to the quiz that you have. Okay, so sometimes you have multiple choice. Sometimes you actually need to actually input the number properly, right? So all of things you need to actually pay attention to. Okay, and then how many times should we do the practice test? Okay, so your target is what? To solve a questions within 3 minutes. That is your target. Okay. In your midterm 1, I forgot how many questions that you have. But if you can just finish one question within 3 minutes, you're probably fine. 23. Okay, thanks for the information. Okay, you have 23 questions for your midterm, and you have 75 minutes. Yeah, so if you can do 3, then that's actually roughly 70 minutes, right? So that's actually the time that you actually targeting for. All right. Can I teach you how to farm the watermelon? I wish I can. I mean, that's actually a long time ago, right? You know, the things I do all the time now is actually I sit in front of my computer. I write. That's actually the only thing I do. Okay, I write the papers. I write a grant application. Okay, I write some proposals that, you know, thinking about how science should actually evolve in my own field. Okay, and then I think about, okay, how to make the hangout more efficient for students. Okay, those are my job. Okay, watermelon is actually so far away from me. Okay, but I do know how to pick out good watermelon to eat though. So, all right. So I think that's actually all the questions we went through, right? So, oh, significant figures. This is actually very important questions. Yeah. Okay. So this has become something that's actually so critical somehow from chemistry department point of view. Okay. Me personally, I think it's actually a good thing to know. Okay. But I have a doubt because I feel like if you actually know how to calculate everything, but then take off all the points because you don't input the correct significant figures, I feel it's actually a bit the purpose. Okay, so but rules are rules. Okay, so what I can say is actually pay attention to the significant figures. Okay, and then if you did not and you lost a point, please reach out to me. Okay, and we'll try to see if there any things that we can do, at least give you some partial credit for that. Okay, but that will actually happen after the exam. Okay, the best part is actually you do know how to actually count the significant figures. All right. So about the questions, okay, so I think let's say so another student asked me, okay, can we actually get more questions? Okay, so I think that's actually the time that you want to actually seek for some help from your classmate. Okay, because everybody have different quiz problems. Okay, so if you can actually exchange the quiz with your friends, then you'll be able to actually prove a larger amount of questions. Okay, and then you will see many of them is actually repetitive. Okay, you want to actually looking for that question that only appear in your friend's quiz, but not in yours. Okay, so once you do that, then you'll be able to prove I would say majority of the question you're going to encounter in your midterm. Okay, and then by doing so, it's actually a lot of effort. Okay, and if you can really do all those things, I'm pretty sure you can do well for your midterms. Okay, so any other questions? Okay, so if not, then let's get started. Okay, so before we get started, I want to thank you to one of the students who actually sent me this. Okay, so you know, as a professor, okay, my job is really doing research, right? But I enjoy teaching so much. And then every time I receive, sometimes I receive calls from students, okay? And then these students, apparently I don't know if he or she is actually a first generation student, okay? I'm the first generation students for my own family, okay? So I know how difficult it is and how challenging it is, okay, to actually enter a university without someone who is actually not enough to help you. Okay, so if you found my lecture helpful, okay, I will be actually very happy to actually hear the information. Okay, and then this, okay, I want to say thank you to you. Okay, this means a lot to me. Okay, I'm a professor who wants to actually get feedback from students. Okay, and then you should also know that, okay, after your midterm, okay, you're going to get 1 extra point if you do the midterm survey. Okay, so I hope everybody will participate. Okay, and then tell me what are the things that you want me to actually improve in the, not the second half, it's actually in the after midterm one semester. Okay, so please do the survey. Okay, that's actually how you get the extra points. All right. And then today, okay, these are the 3 hangouts. I think I've been asking for so many times, right? So these are the hangouts that you have, and the equations on those hangouts are the things that you actually memorize. Okay, and then if you really read through those hangouts, there's actually not many equations that you actually memorize. Okay, we went through the chapter 12 in the previous lecture. Okay, and then specifically we actually went through this. Okay, how to so previously we actually went through this, right? How to actually write the chemical quotient, and then you want to compare the chemical quotient Q to the equilibrium constant K. Okay, so that you can actually predict the equilibrium position, right? So equilibrium position is actually the keywords that we mentioned for this first concept we went through in the previous lecture. Okay. The second one we went through is actually the compute of equilibrium constant, right? So if you actually modulate or modify your chemical equation, okay, and then how your equilibrium constant K is going to change accordingly. These are the 3 rules that we should know, right? If you flip the equation, you put the -1 to the exponent of the equilibrium constant, right? To multiply n, also go to your exponent. If you actually add up 2 equation, then the new K will be the product of the 2 old Ks, okay? The very last one is actually the ice table, right? So we explained to you when you read the questions, okay, you want to know the value provided inside the question, does that belong to your I, C, or E, right? And that's actually the way how you can just figure out the answer for those type of questions. The very last one is actually the Le Chatelier principles. There are only 3 terms is going to affect your equilibrium position, which is actually concentration, pressure, and temperature. Right, so we went through those kind of questions in the previous lecture, and we also tell you that the catalyst is the trap that want to actually let you actually lose your point. Okay, so those are the things we went through for the chapter 12. Okay, so it's not really a long concept. Okay, but these are the key concept and key equations that you need to actually memorize. Okay, you want to actually print all these things into your brain, okay, so they can reuse it, okay? What we're going to do today is actually really using these 2 sheets, okay? Okay, let's start from the chapter 10 first. Okay. So chapter 10 is actually talking about all different kind of concentration unit. Okay, the most important one are these 4, right? So the molarity, normality, mole fractions, mass percent, and the molality, right? So these are the 5 different concentrations that you need to actually memorize. You need to know their definitions. You need to know how to actually write the equations. Okay, so on top of that, you should also know how to compute the number of moles, right? It's actually the mass of your substance divided by its corresponding molecular weight. Okay. So those are the things that you need to know. Okay. And then one very important thing they are going to be asked is actually, can you actually do the concentration conversions? Okay, so we're going to go to a few examples today to, polish those skills. Okay, so let's actually the first part of the chapter 10. The second part is actually talking about the solution formation. Okay, so the key here is that when you actually mix things together, it is actually a favorable process. Okay, if 2 things cannot mix well with each other, okay, then what it says is actually the lattice energy. Okay, so when we see this delta H of solute, okay, one key things that you're going to see a lot is actually called the lattice energy. Okay, that lattice energy is actually so big, okay, that prevent it break apart. Since you cannot break apart, then you can actually mix well with your solvent, therefore you won't be able to have a solution. Okay, so that's actually a key concept that you should know. And this is actually summarized. Okay, the sign of your delta H solution. Okay, if it is negative, it is so-called the exothermic. Okay, so under the case, during this process, you break down all this solute. Okay, it's going to release the heat. Okay, once you release heat, those heat will be absorbed by your solvent. Therefore, the temperature of your solution is going to increase. Okay. In contrast, if your delta H solution is positive, then it's actually an endothermic reaction. Then it's actually to break apart those solute into absorb the energy from your solvent. Okay, so under the case, since your energy from solvent got absorbed to break those bonds, right? So the overall solution temperature is going to decrease. Okay, so this is actually some concept. It's not really calculation. It's just concept that you need to get familiar with. Okay, you once you see the sign of your delta H solution, you can actually predict, okay, how the temperature is going to change accordingly. Okay. All right, the third one is actually the solubility, right? So the main concept of solubility is actually like dissolved light, right? So hydrophilic like hydrophilic, hydrophobic like hydrophobic. Okay. And the way you decide whether it's hydrophilic or not is that you are looking for the OH and NH, right? So those two functional groups will actually dictates whether the substance is actually hydrophilic or hydrophobic. Okay, if you do have land, they are hydrophilic, right? Okay, and factors that affect the solubility, two terms. Okay, one is temperature, one is pressure. Okay, if you increase the temperature, if your solute is actually solid, then the solubility is going to increase. Okay. Pressure-wise, okay, it only actually matters with the gas molecule. Okay, the higher the pressure, you're going to push more gas into your solvent. Therefore, the solubility is going to increase. Okay, so those are the things that highlighted in these sections. Okay. We actually did not use too much about the Henry's law. Okay, but what it says is actually telling you the solubility of your gas is going to can be calculated using the so-called Henry's law constant times the partial pressure of the gas solute above the solution. Okay, so this one is actually, we don't use this one much. Okay, that's something that you probably, if you're a chemistry major, I think you should actually know those things. Okay, but Ross's law is actually the things you probably want to really memorize it. Okay, so this is actually equation that you need to know. If today you throw something into your solvent, okay, and that something is actually non-volatile species, means it doesn't actually contribute to the vapor pressure. Okay, then to compute the vapor pressure of your solution, you will simply equal to the mole fraction of your solvent. Okay, because the solvent is actually the one that's going to produce the vapor pressure times the vapor pressure of the pure solvent. Okay, this little circle represent the pure substance. Okay, so this is actually equation that you're going to use to compute the vapor pressure of a solution with a non-volatile solute. Okay. If your solute is actually volatile, then what you need to do is actually need to compute the corresponding mole fraction and multiply its associate vapor pressure of pure substance. Then you adding up. Okay. So that's actually the vapor pressures. Okay. One very important thing is that the more solute you actually add into your solution, the vapor pressure will decrease, right? Because the amount of solvent, the portion of the solvent is going to decrease. Okay, so since you have less solvent, then you have less vapor pressure. That's actually a concept. Okay. These are the four important concepts for the collective property. Okay, so when you have higher concentration, your boiling point is going to get higher. Okay, freezing point is going to become lower. Osmotic pressure is going to become higher. Okay, so those are the things that you need to memorize. And the equation-wise, you should know the change of your boiling point is equal to I times K times the molality. Okay, I is the Van Hoff coefficient. Okay, so if you have an electrolyte, meaning when you throw this substance into water, okay, it will actually dissociate. Okay, so the number of molecules it dissociate defines your Van Hoff coefficient. Okay, we're going to go through some example like that today too. Okay, so but these are the equations that you need to actually memorize. Okay, and then this is actually the osmotic pressure pi is going to proportional to the Van Hoff coefficient I times the molarity times the temperature. Okay. So let's actually all the things that you need to know for chapter 10. Okay. Chapter 11 is actually all about kinetics. Okay. The first part is actually you need to know if I'm giving you a chemical equation, how you can actually write out the proper red law. Okay. So, and then you should actually have a good understanding. The delta A delta T is representing the change of A. Okay. Doesn't represent the overall reaction rate. Okay, to compute the overall reaction rate, it need to be actually normalized by the coefficients. Okay, so those are the important concepts that you should know. You can actually distinguish all the things. Okay. The second important concept for chapter 11 is actually there are two types of red law. One is called the differential red law. One is actually the integrated red law. To obtain the form of your differential red law, you need to do the experiment, right? Those exponent is actually coming from you do the experiment, you compare the rate, you change the concentration of your substance, okay, and you see how the rate changes accordingly, right? Then you actually compare multiple conditions to figure out the reaction orders for each species, okay? You also need to know the unit of rate constant. Okay, so from the rate constant, you should be able to actually understand the reaction that you have is actually zeroth order, first order, or second order. Okay. For the integrated rate law, these are the three equations that you need to actually recognize, right? So you have zeroth order, first order, second order. Okay, so these are the three that you need to actually memorize. Okay. And the main difference between your integrated rate law and the differential rate law is that in the integrated rate law, you introduce a very important parameter called time, right? Every time you see how long it takes, and you know it's actually integrated rate law, and these are the three equations that you're going to use. Okay. Okay, reaction mechanism is actually the third topic for chapter 11. Okay, so the way you actually solve this type of questions, actually, you're going to given multiple elementary steps, right? By adding up all the elementary steps will give you the overall reactions. Okay, from the overall reaction, you should be able to identify the reactants, products, intermediates, and also the catalyst. Okay, so the red law can be expressed in terms of reactant concentration to whatever exponent that you have. Okay, so you should you need to actually identify what the reactant is. Okay. And then you can actually using these three steps to actually write out, okay, what is actually the experimentally determined red law accordingly. Okay. The very last one is actually the Arrhenius equation. Okay, and this is actually equation that associates your rate constant K with activation energy and temperature. Okay, so every time you see the keyword activation energy at different temperature, you know you need to use the Arrhenius equation. Yes. You mean this two? This? You mean this? I did not know which one you are talking about. This one? So you want to actually differentiate lag from which one? This. So when you are going to use this, so when you see a question that describe, okay, so they give you a chemical equation, okay, then you are telling you one species change certain amount by certain time. Okay, so with that being said, you're going to get information of this, right? And then you will say, okay, so under the same situation, how much change you are going to observe for B, C, or D? Okay, that's actually we are going to use this concept here. Because you know, in order to actually connect this to this to this, they actually all connect back to your rate, right? So in order to connect back to your rate, then this comes into play. Okay, so if the question actually specifically telling you how fast a specific species is changing, and then it asks you how other species is going to change accordingly, then this is actually the equation that you need to use. Okay, so when are we going to use this? This is actually a very standard question that you're going to see the tables. Okay, once you see the tables, then this is actually the equation that you need to use. Okay, so we'll go through a few more examples today, but that's actually pretty much how I will actually distinguish the timing to use different equations. Okay, any other questions? So I went through actually a lot of things very quickly in the beginning of this class. Okay, so if you can follow, that means actually you are doing pretty well. Okay, if you cannot, then go back home and make sure you actually understand the material and come back to today's recordings. Okay, you want to make sure you can actually follow everything I say. Okay. All right, so I think we're stopping here, right? So this actually when you're going to use this Arrhenius equation. Okay. All right, so another thing I want to mention is that the use of R. Okay, so when should you use 8.314 and when should you use actually 0.08206? There's actually only two places you want to use the 0.08206. Okay, and those are the things that when you see gas appear inside your questions. Okay, so what do I mean by that? I equal to IMRT, right? Pi is a property of gas, right? It's osmotic pressure. Okay, in this case, the R need to be 0.08206. Okay. The others is Kp to Kc, right? So you can see it's Kp to Kc, right? Again, the pressure term shows up. Okay, so that's where you're going to use this specific R. Okay, if there's actually no gas appear, then basically you're going to use 8.314. Okay, so yes. Mm-hmm. So you mean K? So if you have Kp equals to Kc times RT, let's say put to the -1 power. So what does this mean? -1 power means what? Yeah, so this is actually simply equals to this. Okay, so if it's actually RT -2 will be just okay. Mm-hmm. All right, any other questions? So if not, then let's go through some of the questions that we want to actually go through from our Hangouts. Okay, so for this question number 1, it says determine the mass in gram of cycloheptane. Okay, so this is actually the molecular weight of lead species. That must be added into this much of benzene to make the concentration solution. Okay, so you want to know how much you need to add into the solvent to make the solution with that specific concentration, right? So what is actually keyword here? So you want to know what concentration they are looking for, right? So what is the concentration that we have here? What is this? Molality, right? So once you select little n, write down the definition of molality, right? So you define the molality equals to number of mole of your solute, right? Over the mass of your solvent, right? Right. So this is actually the first step that you, right? You need to know what concentration term you want to have, right? That's why I say you need to actually know the definition of those 5 different concentration terms. Okay. So once you write these things out, then you start to actually looking for information. Okay, you want to find out the norms. Okay, so what are the things that is actually known? Do you know this? You do, right? The value is, okay, do you know this? The mass of your solvent. Okay, which is, you want to convert to kilogram, right? So this need to divide by 1,000, right? Okay, so do you know this? You don't know, right? But do you know the definition of that? Okay, so how do you define this guy? The mass of your substance, right? Which is C7H14 divided by molecular weight, right? Do you know the molecular weight? Which is 98.2, right? Okay, so with all the things written out, then you can actually write this, right? So you can write 0.599 is going to equals to the mass of your C7H14 divided by 98.2 divided by 60.3 over 1,000. Okay, so you have an equation, right? How many unknown you have in this equation? Only one, right? Can you solve that? Yes, so you can just solve a lot of things, right? So you can actually calculate this and get your mass of your C7H14 is going to equals to, okay, I will just give you the number, 3.55 grams. Okay, so what this means is actually to add in 3.55 grams of your C7H14 into the specific solvent. Then you can get the solution with the specified concentration. Okay, so that's actually the things that you are actually been asking in these specific questions. Okay, so recap the things. Okay, the first thing is actually every time you see these questions, first identify what is the concentration that you have. Okay, the definition of the concentration, right? So here we say in the first thing we do is actually we identify the concentration we are handling here is actually the molality, right? So like we write out the definition of molality. Okay, once you write it out, then you reread your question again. Then you realize you know the information for most of the terms, right? And then the only time you don't know, again, you start from the definition, right? And then you reread your question again and you realize, okay, there's actually only one unknown that's actually things I'm looking for. Okay, so by doing that, you can actually quickly solve the mass of solute that you will need to prepare a specific solution. Okay, so that should be actually a logical thinking that you should have. Okay. Any question for this? Okay, so if not, let's go to the second question. Okay, so this question says, calculate the vapor pressure at a specific temperature in a solution prepared by dissolving certain amount of non-volatile, non-electrolyte glucose into certain amount of water. And then it tells you the vapor pressure of water is that much. Okay, so what is this question asking? The vapor pressure of a solution, right? And then it provides a bunch of serious information for you, right? Which is somewhat scary. Okay, but you need to know that the thing that you want to know is actually the vapor pressure P of your solution, right? Do we have a question for the vapor pressure of the solution? There's actually only one. Okay. So I hope you see the power of this slide, of this hangout. You're going to find all the equation you need on this free hangout. All, okay. All you do is actually really get yourself familiar with all this equation and memorize it. Okay. If you don't have time, if you haven't started, don't even read the textbook. You don't have the luxury. Okay. Read hangout. Okay. So you know, for a solution, to calculate the vapor pressure of a solution, use this route law. Okay. The P solution means actually the vapor pressure of your solution is going to equals to the mole fraction of your solvent multiply the vapor pressure of your pure solvent. Okay. Once you write out this, okay, go back and read the question again. See what other things that you know. Can actually associate some of the numbers into this equation. What is the number? So you need to know what is your solvent, right? So what is your solvent in this question? Water, right? So this actually tells you the vapor pressure of water. Do you see the information of the vapor pressure of water? Okay, what is that value? Okay, so which term in this equation corresponding to that value? So you have this, right? Okay, so now things actually become very clear. This guy is actually the things you want to solve, right? P solution is actually the one you are looking for, right? You know this term. Now the only thing you need to know is actually your mole fraction of your solvent, right? So in your question, you don't have this information. And that's why you need to know the definition of mole fraction of your solvent, right? So what is the definition of mole fraction of your solvent is? Mole of your solvent, okay, over total is good, okay. Right, so that is actually how you calculate that mole fraction of your solvent, right? Can you calculate the mole of your solvent? Right now you should actually know very well, right? The mass over the molecular weight, okay? So the mass of your solvent is what? 129.7 gram, right? What is the molecular weight of water? 18, right? That's actually something that you should know, okay? So this is actually the same. Okay, so that's actually more of your solvent. How about the more of your solute? What's your solute? Your solute is the sucrose, right? It's 37.63. That's how much solute that you have, right? We also know the molecular weight, which is 342.3, right? Okay. You got all the information here, right? Can you calculate mole fraction? You should be able to calculate it, right? Once you know that mole fraction, you know the vapor pressure of your water. Can you compute the vapor pressure of your solution? Okay, it is less simple. Okay, that's actually how you get the answer. Okay. Any questions so far? No questions? Everyone understand how this works? Okay, these are the variants. Okay, you want to know. I want to actually draw your attention to here. There are two keywords here. One is called the non-volatile. Okay. The other one is called the non-electrolyte. So this actually has a very specific meaning. Non-volatile actually tells you that you need to use the Raoult's law. Okay. So remember in our hangouts, this is actually if your solute is non-volatile. Okay. But if your solute is actually volatile, you will need to actually do this calculation for each individual component and add it up. Okay. So to explain this one, what it really means actually the mole fraction of your solvent times the vapor pressure of your pure solvent plus the mole fraction of your solute times the vapor pressure of your solute. Okay, so if your solute is also volatile, that means it's going to produce vapors. Okay, then this is actually the equation that you will need to use. Okay, but because in this question it says it's non-volatile, right? Therefore, you know, all you need to have is actually this Raoult's law. Okay, so let non-volatile mean something. You need to know the differences. Okay, yes. Depending on how the question is going to ask it. If the X was 4, then use 4 all the way. If on X ATM, then use ATM all the way. Okay, just make sure your unit is actually consistent throughout. Okay, so that's actually the first important point. Okay, how about the second one? Non-electrolyte. So remember when we talk about the vapor pressure, when we talk about the boiling point, freezing point, and osmotic pressure, there's actually a very important thing called the Van Hoff coefficient I, right? When you see this non-electrolyte, means I is going to equals to 1. Okay. This means I equals to 1. Okay, so this is actually what it really want to tell you. The I equals to 1. Okay. And then the non-electrolyte tells you need to use the Raoult's law. Okay. So those are all the possible tricks you probably will just see. Okay, those are the variants you probably will see in your midterms. Okay, any questions? Okay, if not, let's go to question number 3. So here it says consider solution. Okay, you have 3 different kinds of solution. This is one, second one, and the third one. And it asks you which one has high is osmotic pressure, low is vapor pressure, and the high is boiling point. Okay, so osmotic pressure, freezing point, boiling point are the keywords for collective property, right? So in the collective property, let you know The first one is actually so-called the vapor pressure lowering. Okay, what it says is actually if you have higher concentration, they're going to have lower vapor pressure. Okay, so the first one is okay. The second one will be boiling point elevation, meaning if you have higher concentration, you're going to have higher boiling point. Third one is freezing point depressions, right? Meaning higher the concentration, lower the freezing point. The very last one is osmotic pressure. Okay, is I should say a higher osmotic pressure. Okay, when you have higher concentration, you're going to have higher osmotic pressure. So these are the four concepts that we learn from the collective property. Okay, so now you want to actually know what is actually effective concentration. Okay, so you have three candidates. One is urea, one is AgNO3, one is CaCO2. Okay, so the question will give you certain concentration. Okay, so in this case, you can see the concentration that was given is actually all the same, right? 0.04 m. Okay, so this is a very, very standard question trying to testing whether you know how to compute the Van Hoff coefficient. Okay, because the effective concentration will be whatever concentration they give you multiply the Van Hoff coefficient I. Okay, so what is the I of this urea? 1. How do you know it's 1? Yeah, it's actually organic compound, right? So 99%, okay, 99, okay. Most of the organic compound doesn't serve as electrolyte, so they don't dissociate. Okay, so the I is equals to 1. How about your AgNO3? So this is a part sometimes students get confused. Okay, you want to know Ag like to exist in 1 plus. Okay, so if you are chemistry major, I hope you actually know the things. Okay, so AgNO3 it will dissociate become Ag plus NO3 minus. Okay, so the I is going to equals to 2 here. Okay, CaCO2. Okay, so this will be Ca2 plus 2 Cl minus. The I is equals to 3. Okay, so for the effective concentration, which one is actually highest? CaCO3, right? Because the effective concentration, so let's call the N effective, is equals to whatever concentration you are assigned, multiply your I, right? So I times M is actually your effective concentration. Okay. So from here, since their assigned concentration is all the same, right? So the effective concentration will be determined by your Van Hoff coefficient. Since your CaCO2 have the largest Van Hoff coefficient, okay, then it has highest effective concentration. Who is actually second? AgNO3, right? And then it will be the urea, right? Okay, so now with all of things being said, you can start to predict, okay, who is going to have the highest or lowest vapor pressure, okay? For the vapor pressure, we know the higher the effective concentration, the lower the vapor pressure will be, right? So who is going to have the lowest vapor pressure? CaCO2, right? So this one will be the lowest, right? Who is actually the highest one? Urea will be the highest one, right? How about the boiling point? Which one is going to give you the highest boiling point? CaCO2, right? Who is going to give you the lowest freezing point? CaCO2. Which one will give you the highest osmotic pressure? CaCO2. Okay, so this is actually how you make all this judgment. Okay, so with all of things being said, come back to here. Who is going to give you the highest osmotic pressure? You're actually looking for the one with highest effective concentration, right? So in that case, you know the answer will be CaCO2. Okay. Lowest vapor pressure. Okay, the higher the concentration, the lower the vapor pressure, right? So you know this is also CaCO2. Highest boiling point, the higher the concentration, the higher the boiling point. So this is also CaCO2. Okay, so these type of questions you can see over and over again, but key is that you want to know, okay, how to compute the effective concentration. Okay, you want to know how to actually, from the formula to predict what is the Van Hoff coefficient I. Okay, so those are the most important part for this type of questions. Okay. All right, any questions for this? Yes. How do I? So organic compound is actually the things that you only see CHONS. Pretty much that's it. Okay. So if you don't see these metals, okay, most of the time it is organic compound. Okay, so next questions. The chloride dissolved in water according to this, the tin chloride, okay, not the chloride, tin chloride, which is this equation. What is the boiling point of the solution when that much of solute is dissociated in that much of water? And it gives you a Kb of a certain value. Okay, so what is the keyword here? I did not actually highlight the keyword. Boiling point, right? So once you see boiling point, you should associate with collective property, right? And then vapor pressure lowering, boiling point elevation, freezing point, depression, okay, and the osmotic pressure are the four, right? So here you're talking about the boiling point, then the equation that you have is actually delta T is equal to I times K times M, right? So those are the equations that you need to memorize. Okay. So the delta T is the change of your boiling point, right? Once you write the equation out, again, go back to read your questions, right? Anything that you know. KB is 0.512. Okay, what else do you know? Do you know I? What is I? The value of I is equals to 5, right? How do you know it's 5? 1 plus 4, right? So you know this actually 1 SN4 plus 4 CO minus. So your I is equal to 5. Okay. Do you know the molarity? Do you have the molarity information directly? You don't, right? But do you know the definition of molarity? See, if you don't know what it is, then you need to know its definition, right? Which is the moles of your solute divided by mass of your solvent in kilogram, right? Do you have any of this information? The mass of your solvent is 10 gram, right? That's actually water, so to actually make it become kilogram. How about moles of your solute? So that is actually your mass, right? 0.2005. Molar mass is 260.5. Okay. So this thing will give you what? Will give you that, right? Will give you the molarity, right? So now you know your I, now you know your K, now you know your molarity. Can you calculate your delta T? Okay, so once you do that, you should be able to find out your delta T is going to equals to 0.256. Okay, so the delta T means the change of your boiling point, right? But the question is actually asks you what is the actual final boiling point of your solution, right? So what you need to do is actually you know the boiling point is going to increase, right? Boiling point elevations, right? So the boiling point of your solvent in this case is water, right? So under these specific questions, then you know the normal boiling point of water is 100, right? So your temperature of your boiling point will equals to 100 plus your delta T, which equals to 100 plus 0.256. That give you a final answer of 100.256. So this will be actually your answer. All right. Okay, next questions. Okay, so read this question again. Okay, I guess I was just go through these questions, tell you how you should actually proceed. Okay, we can actually go through the step-by-step calculation for this one. Okay, so we say if there's actually 5.6 of unknown non-electrolyte is dissolved in certain amount of acetone, the boiling point increased by that much. Okay, if the Kp is known, calculate the molar mass of this unknown solute. Okay, so what is the keyword here? The boiling point. Okay, once you see the boiling point, the equation you use is actually delta T is equal to I K M. Okay, and then what is your I? 1, right? Because it says non-electrolyte. Okay, so this tells you I equals to 1. Do you know your K? You do, right? And then the only thing again that doesn't give you directly is actually your molarity, right? So since it doesn't give you, then you need to actually define the definition of molarity. Okay, and then from there, you know your molarity is number of mole of your solute over the mass of your solvent in kilogram, right? What is your solvent here? Yes, so that is this. Okay, the moles of your solute will be the mass of your solute divided by the molecular weight, right? Do you know the mass of your solute? You have 5.6, right? Okay, so you know this guy is going to equal to 5.66 divided by the molecular weight. Okay, so that is actually the things that this question is asking for. Okay, so you know the delta T, right? Because it tells you the change is actually 3.8, right? I is 1, K is 1.71, M is on the top is actually 5.66 divided by the molecular weight. Bottom is 50 divided by 1,000, right? So the only unknown is actually your molecular weight, right? So using this equation to solve it, that's how you do it. Okay. Next. Okay, so calculate the molarity of a solution that has 8.1 mass percent. The density of the solution is actually 1.1 gram per ml. Okay, so in these questions, what are the keywords? Mass percent, what's the other one? No, density is actually not. Okay, so you see two concentration term appear in one single question, right? That is actually a very, very standard question to ask you, can you do the concentration conversion? Okay, if you see two concentration units appear in one single question, that is a question to test you, can you do the concentration conversion? Okay, so we have a hangout to tell you how to do the concentration conversion between different units. Okay, so this is actually one example. Okay, so how do you actually start from here? You start from the known to the unknown. Okay, so the known one is what? The mass percent, right? And then you want to go to molarity, right? So that is actually a process you want to go. Okay, so the mass percent is 8.1%. Okay, you first need to know what is the definition of mass percent, right? So the mass percent is really the mass of your solute divided by the sum of your solute and the solvent, right? So, and then multiply 100%. That's actually how you define your mass percent. Okay, so we say if you start from mass percent, the best way to actually, you want to do some assumption, right? You want to assume that the mass of your solvent plus the mass of your solute equals to 100, right? So once you make the assumption, then you can actually say the mass of your solute is equal to 8.1. The mass of your solvent is going to equals to 91.9. Right? So with the mass of your solute equals 8.1 gram. Okay, so these are the information that you can know here. The next thing you do is actually you want to know the definition of your molarity. Right? So what is the definition of your molarity? The volume of your everybody get confused, right? Okay, so how to actually memorize when you use solvent, when you use solution? There's actually only one concentration use solvent as the denominator. Only one, molarity. All the others, the denominator is actually the property of your solution. Okay, for example, the mass percent, right? The mass percent, the denominator is actually mass of your solvent plus mass of your solute, which is the mass of your solution. Okay, so every single concentration term using the property of your solution as a denominator. The only exception is your molarity. Okay, I hope they will actually remove those confusion that you're going to have. Okay, everybody have this confusion. Okay, but if I point out, only the molarity is the one using solvent as your denominator. Okay, I think it will actually help greatly for you to actually know what is the property you should use. Okay, so with that being said, this is actually how you define your molarity, right? Okay, so then you start to looking for the information that you have and the information you are missing. Do you know the moles of your solute? You don't have the information on the questions, right? So if you don't have the information, what do? Write out the definition of that term, right? This will be the mass of your solute divided by the molecular weight of your solute, right? Do you have the mass of your solute? You do, right? So this one is actually 8.1, right? Can you actually compute the molecular weight of that chemical? You can, right? So this term, now you know you can actually get the value of that, right? So what it tells you is that, okay, the only thing you will need to know is actually the volume of your solution, right? So that is actually things that you don't know, but you want to know. So how do you actually know the volume of your solution? So here you know the density of your solution. Okay, so you know the density of your solution. What does density mean? The mass over volume, right? The mass of your solution divided by the volume of the solution give you the density of your solution. This term are the same, right? That is the term that you are looking for. Okay, so with that being said, you know the volume of your solution can be computed by the mass of your solution divided by the density of your solution. Right? If you figure out this, then you know the answer, right? Do you know the mass of your solution? What is that? 100, right? 100, not 91. The mass of your solution is actually 100, right? Do you know the density of your solution? 1.1, right? Can you compute the volume of your solution? Okay, make sure it's actually in liter, then put it back, then you get the answer. Okay, everybody follow? Yeah, I'm going a little bit too slow for these things. Okay, so I want to actually talking about a few examples for chapter 11. Okay. So this is actually somewhat related to the question that you asked in the very beginning. Okay, how to actually determine the order of your differential rate law? Okay, so if you see something like this, right? It gives you the rate, and then it varies the concentration of each terms, right? So what you will need to do is actually write out your differential rate law. Okay, for example, here you can write out 3.7 times 10 to the negative 7 is going to equals to the rate constant K times reactant here is ICL, right? Which is 1.5 to the X power, 1.5 to the Y's power. That's actually your equation number 1. Equation number 2 will give you 15 times 10 to the negative 7 will give you K times 3 to the X power, 1.5 to the Y's power. Okay, then use 2 divided by 1. Okay, on the left-hand side, you're going to a value of 4 is going to equal to K, and K is going to cancel out to the 2 to the X power. Then you can figure out the X is going to equals to just 2. Okay, then you can repeat this analysis using the third equation. And then using equation number 3 divided by equation number 2. I will choose 2 here, right? Because your X, your first, this concentration is the same. Then you can use that to compute your Y. Okay, then you'll be able to figure out the overall reaction order. Okay. We went through a question very similar like this in the previous recording. Okay, so if you are not very familiar with what I'm talking about, then go back to that recording to check it out. Okay. All right, so number 9. So this question says, which will be the rate law for the proposed mechanism for the reaction below? Okay, so it gives you 3 elementary steps, right? So what is the first thing you do? You're adding up, right? So if you're adding up, you will see this 2i is going to cancel out with 2i, right? H2I will cancel out. So you know the overall is actually I2 plus H2 that give you 2HI. Right, so that's actually the net chemical balance chemical equation. Right, so you know, if you have a red law, it must have a form like this. Rate equal to K times your reactant to certain power. Right, so the final answer must have some form like this. Okay, so that is actually things that you need to know. It has to contain only the reactant term. Okay, once you identify what your reactant is, then the next step is actually you go to the slow step, right? Then you can actually write out the rate. It's going to equals to rate constant K times whatever species that you have here. Okay, so in this case, what you have is actually I2, right? So once you write it out, this is actually a rate law you can get from that rate determined step. Okay, then what? Then you look at your rate law. Okay, does it only contain the reaction? So in this case, it only contains the reaction, right? Nothing else, right? So if that's the case, end of again, right? That's it. That's actually your answer. Okay, but if it is not, then most likely you're going to use the equivalent constant equation to substitute those non-reactants until your rate law only contains the reactants inside your equation. Okay, right. So next question. Okay, so I want to talk, I guess this will be the very last one we can talk about, okay, for the interest of time. The reaction A become B plus C is a second order in A. When the initial concentration A equals 0.1 m, the reaction is 20% complete in 26.2 minutes. Calculate the value of your rate constant. Okay, so you know the things you want to calculate is what? A rate constant K, right? So when we read these questions, what is the keyword? Secondary is one. There's another one. 20% complete is another one. That's actually the most important one. There you go. 26 minutes. What do you learn from that information? Integrated rate law. What order? Second order. What equation? What equation? What? That's the things that you actually memorize, right? So it's actually 1 over AT equals to KT plus 1 over A0, right? So now you actually have the equation. Then what you do next is actually read the question and figure out the things that you know, right? What are the things that you know? Pi is 26.2. And then A0 is this, right? So let's see your A0. Do you have your AT? What does this mean? 20% complete. What should you put here? So this is actually 0.1, right? You only have 20% complete, meaning how many remains? Yeah, so there will be point. Okay, so you have your AT, right? You have your T, you have your A0. Can you calculate the K? Yeah, that's how simple it is. The trick here is actually, can you actually recognize the word complete, right? That's actually the trick here. Okay, if there's remains, then you just put 0.02 over there for your AT, right? But here it says complete. So you need to actually do 0.08 for your AT. Okay, so I'm sorry I did not actually finish all of them, but I believe we went through this one. Okay, 11 is actually the one we went through last time. And then the 12 12 is actually testing the rate constant unit, okay, which is actually on our Hangout. So make sure you actually know those equations on our Hangout. This one is interesting one, but we also went through it kind of last time, right? So you need to actually to identify the reactant, product, intermediate, transition state, activation energy, endothermic or exothermic, okay? And then the very last one, no, that's all. Yeah. Okay, so good luck with your exam. And then if you have more questions, feel free to find me tomorrow all the way until 3 p.m. All right? Good luck.